You can solve a system of linear equations using the substitution method, or you can solve it using the elimination method. And we're going to take a look at that next. Welcome to Math Bytes. I'm Allison, and today we're talking about the elimination method for solving a system of linear equations. It's called the elimination method because it involves eliminating a variable from the system of equations. Now we're going to go through several examples so you can see how this works. If you have any issues with the algebra we're doing here, be sure to watch the Math Bytes series on solving basic algebraic equations. It covers all of this. Let's do an example to see how the elimination method works. So I have this system of equations. X plus 2y equals 6 and negative x plus y equals 3. Now, what if I add those equations together? So I'll just add the two equations that make up my system. So that means adding like terms, x plus negative x is just 0, so the x goes away. And that leaves me with 3y equals 9. Now, multiplying both sides by 1/3 to solve for y, I get that y is equal to 3. Okay, well now I know what one of my variables is. So I can plug that value of y into my first equation to get x. So I get x plus 2y equals 6, and plugging in that 3, I get x plus 2 times 3 equals 6, x plus 6 equals 6, or x equals 0. So the solution to this system of equations is the ordered pair 0, 3. Now in our last example, all I had to do was add my two equations together, and that eliminated one of my variables. But what if I have something like this? 6x plus 5y equals 1 and x minus 3y equals 4. Now if I just add these equations together, that's not really going to get me anywhere because it's not going to eliminate either one of my variables. But what if I multiply one of my equations by a non-zero number and create an equivalent system? Suppose I multiply equation 2 by negative 6. So that would give me negative 6 times quantity, x minus 3y, is equal to 4 times negative 6. And that gives me negative 6x plus 18y equals negative 24. Now, let's use that equation instead of our original equation 2 and add the equations together. So I get 6x plus 5y equals 1 plus negative 6x plus 18y equals negative 24. Now, when I add those together, the 6x and the minus 6x become 0, and the x goes away. And I'm left with 23y equals negative 23, or y equals negative 1. Now I have a value for y. So I can plug that into my equation 1 and solve for x. So I get 6x plus 5 times negative 1 is equal to 1. And that gives me 6x minus 5 equals 1. Adding 5 to both sides, 6x equals 6, or x is equal to 1. So the solution to this system of equations is the ordered pair 1, negative 1. That's how the elimination method works. You multiply one of your equations by a non-zero number, such that when you add your equations together, you eliminate one of the variables. Okay, let's do one more example. I have the system 3/4 x plus 1/3 y equals 1 and 1/2 x plus 2/3 y equals 0. Now, I know this looks a little bit icky with the fractions, but again, I'm just looking for a non-zero number to multiply one of my equations by, such that when I add it to the other equation, I get rid of one of my variable terms. What if I multiplied equation 1 by negative 2? That would give me negative 2 times quantity, 3/4 x plus 1/3 y, is equal to 1 times negative 2. That gives me negative 6/4 x plus negative 2/3 y equals negative 2. And reducing, I have negative 3/2 x plus negative 2/3 y equals negative 2. Okay, so I'm going to replace equation 1 in my system and then add together. So I have negative 3/2 x plus negative 2/3 y equals negative 2 plus 1/2 x plus 2/3 y equals 0. Okay, so I have -3/2 x plus 1/2 x. That gives me -2 over 2x. My y terms cancel out because I have 2/3 y plus -2/3 y. And that's equal to -2 plus 0, which is just -2. So that gives me -1x equals -2, or x is equal to 2. Okay, now I have a value for x. So I'm going to plug that into equation 2 and solve for y. So I get 1/2 times 2 plus 2/3 y equals 0. That gives me 1 plus 2/3 y equals 0, or 2/3 y equals -1. Multiplying both sides by 3/2, I get y is equal to -3/2. So the solution to this system of equations is the ordered pair 2, -3/2. I think with these two variable systems of linear equations, sometimes it's typical to gravitate towards the substitution method. It seems a little more straightforward maybe. But often with the elimination method, you do less algebra. So keep that in mind and use whichever method makes the most sense for the system you're trying to solve. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com. And we'll see you next time.